What are you making, little kitty? For that, you'll need more than just clay.
Why?
That's an excellent question. Hey friends, in today's episode, let us see the process behind the creation of our beloved planet and answer a crucial question. How did the Earth form? Zoom in! Planet Earth, a giant mass of water and mud revolving in space, and the only known home sweet home formed just for us, as it gives us food to eat, water to drink, and air to breathe, making it a perfect breeding ground for life to evolve. But have you ever wondered, how did this giant planet come into existence in the first place? I'm sure you did. So, let me tell you this astonishing story of the Earth's formation. Well, it all began a long time ago, which is about 15 billion years ago, when the whole universe was inside a tiny bubble called the cosmic egg. Then about 13.8 billion years ago, the little ball bubble began heating up and generating energy until it finally exploded with a bang. Today, we call this massive explosion the Big Bang. You can check our video on the same. The link is in the description. Then about 4.5 billion years ago, when the universe began to cool down a bit and settled into its current layout, everything started to spin, forming mighty wind and gravity. And over time, one such gravitational force from the remnant of a dead star started pulling the giant dirty gas cloud. This cloud got denser and denser in its center and formed an accretion disk. Then, in the next 10 to 20 million years, other small particles of dust, rock and gas started sticking together, creating larger objects, until it became a sphere and large enough to be called a planet by today's standard, and young Earth was formed. At this point, the Earth's surface temperature was a burning mess, with seas of lava and a poisonous atmosphere. Not only that, various comets, asteroids, and other cosmic elements constantly attacked it from all sides, making it boil more and more. But soon, things took a dramatic turn and the cosmic attack reduced. And so, as the temperature of the Earth cooled down, water from the inside of the Earth rose to the surface, formed steam, and rained back on the ground to form oceans. Even other meteors brought more water to our land in the form of ice. So gradually, the Earth cooled down and the surface formed a thin crust. Meanwhile, the volcanoes on the ocean's bed blew magma to the top, which eventually cooled down to form volcanic islands that joined together to create a single giant continent called Pangaea. And inside the Earth, the hot rock continued to move around, moving the crust below and breaking it apart through a process called plate tectonics. We have a separate video dedicated wholly to this topic. Please check the link below. And as the Earth's crust moved around, Pangaea broke apart and its pieces drifted away to create the continents we see today. And modern Earth took its form, a place we all can proudly call home. Trivia time! Did you know April 22nd every year is observed as Earth Day? Yes, it was first organized in 1970 to promote ecology and raise awareness of the growing problems of air, water, and soil pollution. So, please do your bit and share this video with friends and family.
Hope you learned something new in today's episode. Until next time, it's me, Dr. Binocs, zooming out.
Never mind.
Oh no, little kitty, the earth isn't flat from the top. It's all around, round and round. Plus, a chainsaw isn't a thing to play with.
Oops, sorry.
Phew. Now, let me tell you about the shape of our earth. Hey friends, we all know, apart from the flat earth community, we all know that the world is round. But have you ever wondered why? Well, in today's episode, let us go around this question to find the answer. Zoom in. If you look at our solar system, you will see planets made of rocks, gas with rings. Without them, some are small in size while others are big. But one factor common in all is that they are round shaped. Yes, but the vital question is, why is that and what is the reason behind their round shape? Before we dwell on their shape, let us see, when do we call a celestial body a planet? Well, according to IAU, for a celestial body to be called a planet, it needs to fulfill 3 essential criteria. First, the object should revolve around the sun. Second, the object should be spherical. And thirdly, the area around its orbit should be clear and should not have any equivalent or a bigger celestial body. Meaning, with the help of its gravity, the planet should clear asteroids and dwarf planets out of its way. So, the point number 2 clearly states that the planet needs to be round or spherical. But we don't see any other shape hovering in space in the first place, isn't it, friends? Most things we see are round or pretty close to it, including asteroids. So, what's going on here? Well, the answer is gravity. Yes, Earth and other planets are round because of the force of gravity that pulls equally from all sides. Gravity pulls from the center to the edges like the spokes of a bicycle wheel. This makes the overall shape of a planet round, which is a 3-dimensional circle. But planets are not exactly round, but roughly spherical or oblate spheroids. Yes, if noticed carefully, you will see that the equatorial diameter of the Earth is about 43 kilometers larger than the polar diameter. This is because, just like a spinning top, our Earth spins on its axis with a speed of 1674.4 kilometers per hour. And this much velocity causes the planet to bulge near the equator due to centrifugal force, as things near it tend to move away like mud flying off a tire. And it's not just the Earth, but Saturn bulges the most of all the planets in our solar system. Yes, if you compare the diameter from pole to pole to the diameter along the equator, it's not the same. Saturn is 10.7% thicker around the middle, while Jupiter is 6.9% thicker around the middle. So, instead of being round like marbles, they are like basketballs squished down while someone sits on them.
Trivia time!
Did you know Earth and Mars are small and don't spin around as fast as the gas giants like Jupiter, Saturn, Uranus and Neptune? Also, Jupiter is known to be the fastest spinning planet in our solar system.
Hope you learned something new in today's episode. Until next time, it's me, Dr. Binocs, zooming out. Never mind.
There is nothing more magical than seeing the sun go down on the dusky horizon.
Where did the sunny go?
It's not the sun that goes anywhere during the dawn and sunset, but it's us who move, little kitty.
Kitty's standing still.
Yes, little kitty, it may appear like that, and although we might not feel it, our planet is continuously rotating and revolving on its axis. Hey friends, so in today's episode, let us debunk the mystery behind our beloved sun's hiding spot by learning about our Earth's rotational and revolution movements. Zoom in! So, what are Earth's rotation and revolution? Well, here is a gorgeous illustration of our planet Earth. Now, imagine a line passing through its center of mass. This imaginary line is called the axis. And our planet spins around on this invisible line just like a top. And the circular movement of an object spinning around its axis is called the rotation. Yes, my dear friends, and due to this rotational quality of our planet Earth, we witness day and night. And how is that? Well, it is because different parts of the planet are facing towards the sun or away from it. Yes, my dear friends, when you are located on the side where you can see the sun and its light and heat can reach you, it's daytime. And when the Earth spins to take you away from the sight of the sun, where its light and heat can't reach you anymore, it's night time. And it takes 24 hours for the Earth to turn all the way round to make a single day. I know you guys must be thinking that if the rotation of the Earth makes a day, then what makes a year? And the answer to this question is the revolution. Let me explain. You see, although the Earth is rotating on its axis, at the same time it also revolves on orbits around the Sun, which is called revolution. And one full orbit all the way around the Sun is one revolution. And the Earth takes 365 days, or precisely 365.242 days to complete a revolution that makes up a whole year. But don't get confused with the similarities of the words rotation and revolution, my dear friends. In astronomy, the word rotation is used to mean the movement around the axis, which creates the day and night on Earth, while revolution is used when one body moves around another that makes a year, in the case of our planet Earth. But here is a twist, and that twist is in the axis, as the Earth is not sitting with a straight posture, but its axis is actually a little tilted. Yes, ions ago, when an object the size of Mars crashed into the newly formed planet Earth, it knocked our planet over and left it tilted at an angle. And this slight tilt made one part of the Earth lean towards the Sun, while the other part of it is leaning away. And there is a great significance to this tilt, my dear friends. Yes, due to this angle, the solar energy reaching different parts of our planet is not constant but varies during the year. As at a particular time, the northern hemisphere is leaning towards the sun while the southern is leaning away. And at other times, the southern hemisphere tilts towards the sun, whereas the northern hemisphere leans away. And this is why we have different seasons and why the seasons are opposite in the northern and southern hemispheres. Yes, the part of the earth leaning towards the sun causes summer in that region, and the days are long, while the part leaning away experiences cold climate with shorter days. So, here we go, friends. Now you know the difference between Earth's rotation and revolution, and why they are essential to make your world go round and round.
Trivia time!
Did you know the angle made by the axis of the Earth, which is an imaginary line with the orbital plane, is 66 degrees? Also, it is said that humans have made a moderate change in the Earth's rotation period by several microseconds by accumulating vast reservoirs with trillions of tons of water. Hope you learned something new in today's episode. Until next time, it's me, Dr. Binocs, zooming out. Oh, never mind.
Hello, friends. The best part of a pizza is its crust. Yummy. Just like this pizza, the Earth too has a crust, but with no cheese in it. So, let's learn something about the structure of the Earth today. It consists of the crust, mantle, and core. Zoom in! This is the Earth's crust. It consists of all kinds of rocks, soil, and everything you see above the Earth's surface. You will be surprised to know that the crust, that is the land on which we walk, is almost 3 times thicker than the crust under the oceans. And it extends to about 25 miles. The Earth's crust floats on this layer, which is called the mantle. It is made of thick, solid, rocky substance and amounts to about 85% of the total mass of Earth. The first 50 miles of the mantle consists of very hard, rigid rocks. The next 150 miles are made up of super hot, solid rocks. Below that, for the next several hundred miles, the Earth's mantle is believed to be made up of very solid and sturdy rock materials. The mantle is about 1,800 miles thick and by far the largest layer of Earth. The Earth's outer core is made up of super hot liquid molten substance called lava. This lava is believed to be made of iron and nickel. It extends to a depth of 3,000 miles beneath the Earth's surface. And finally, we have reached Earth's inner core. The inner core extends another 900 miles towards the center of the Earth. It is believed that this inner core is a solid ball made of iron and nickel. Trivia time! The crust occupies less than 1% of Earth's volume. The inner core is the hottest part of the Earth, and it is as hot as the surface of the sun. Surprising, isn't it? Looks like it's time for me to zoom out before I get baked in this heat. Tune in next time for more fun facts.
What, Dr. Painty?
The highest landform in the world, little kitty.
Landform?
Yes, little kitty. Hey friends, in today's episode, let me take you around the globe to witness the natural beauty our Earth is blessed with, known as the landforms.
and briefly explore their exciting formation process with stunning graphics from our creative team. Zoom in! So, what are the landforms of the Earth? Just like all living beings have certain physical features that distinguish them from each other, similarly, the planet Earth is made up of various unique features and characteristics we call landforms. Yes, my friends, the landform is the natural geographical or physical features of the Earth that are classified into various types such as mountains, hills, valleys, plateaus, plains, etc. But before we shed some light on these types of landforms, let us briefly examine the process leading to the formation of these features. First comes the external process, in which external factors such as wind and rain shapes the Earth's surface by erosion and deposition. Yes, erosion is a process in which sediments get deposited in a different location, whereas sediments are the materials on the Earth's surface, such as soil and rocks. Next comes the internal process, and as the name suggests, it is the process that occurs inside the Earth's surface, such as plate tectonics and volcano eruptions. These occur because of the extreme heat in the Earth's core, causing the molten rock in the mantle layer to move, as a result, causing uneven movement on the surface. These layers are either uplifting or sinking, forming different types of landforms that can be categorized into mountains, plateaus, and plains. So, let us explore these major types of landforms, starting from the mighty mountains. Mountains are landforms higher and steeper than the surrounding areas. In general, the mountains are higher than 200 feet and divided into three categories: fold, block, and volcanic. Yes, when two tectonic plates collide and the edges of these plates fold because of the tremendous force between them, it creates the fold mountains. On the other hand, the block mountains form when large areas are broken and displaced vertically. These large areas of rock, sometimes stretching across hundreds of kilometers, are created by tectonic and localized stresses in the Earth's crust. And the third type of mountains are the volcanic mountains that are formed due to the magma flowing up from the mantle to the crust of the Earth. Next comes the plains. Most of the Earth's surface consists of low and high plains that are flat, or the low relief areas on the surface of the Earth. These are the most fertile region of the planet and are the most suitable for human habitation and agriculture activities like farming and poultry. It might be formed as a result of the sedimentation of eroded soil from the top of the hills and mountains, or due to flowing lava deposited by the agents of wind, water, and ice. Now, let us look at the landform we call plateaus. A plateau is a flat, elevated landform that rises sharply above the surrounding area on at least one side. Plateaus occur on every continent and take up a third of the Earth's land and are divided into two categories: dissected plateaus and volcanic plateaus. A dissected plateau forms due to the upward movement in the Earth's crust caused by the slow collision of tectonic plates, whereas a volcanic plateau is formed by numerous small volcanic eruptions that slowly build up over time, creating a plateau from the resulting lava flows. And the fourth major type of landform is the ecological landscape, known as the deserts. It is a dry piece of land with little or no vegetation due to lack of rainfall. In deserts, the atmospheric air is arid and the daytime temperature is high. The process by which fertile land becomes desert is called desertification. You won't believe, but human activities are a primary cause of desertification. Yes, these activities include overgrazing of livestock, deforestation, overcultivation of farmland, and poor irrigation practices. Overgrazing and deforestation remove plants that anchor the soil. As a result, wind and water erode the nutrient-rich topsoil. Also, hooves from feeding livestock compact the soil, preventing it from absorbing water and fertilizers. Trivia time! Did you know the largest plateau in the world is the Tibetan Plateau, located in Central Asia? Yes, it stretches through the countries of Tibet, China, and India and occupies an area of 2.5 million square kilometers. Also, landforms can exist underwater in the form of mountain ranges and basins under the sea. The Mariana Trench, the deepest landform on Earth, is in the South Pacific Ocean. Hope you learned something new in today's episode. Until next time, it's me, Dr. Binocs, zooming out. And the painting is done. Never mind. Hey Kitty, look. A 17-year-old intern at NASA has discovered a new Earth-like planet. Isn't that brilliant?
Let's go there.
I understand your curiosity, Kitty. But one day we might be able to settle on a different planet. But it's possible only if the new world has all the 4 major domains of Earth present on it. It's domains, Kitty. Hey friends, it is rightly said that heaven is under our feet and over our heads. But no wonder we fail to acknowledge it. So, in today's episode, let me tell you about those 4 major domains of the Earth that make our Earth indeed a heaven. Zoom in. So, what are the 4 domains of Earth? The massive universe, formed millions of years ago, has infinite undiscovered spaces, trillions of stars, millions of galaxies, and the 9 planets in our solar system. But the universe blessed planet Earth with living beings. And to make life possible, 3 different components meet so humans can survive and thrive. These are the elements of land, water, and air. These are nothing but the domains of the Earth, namely the Lithosphere, Hydrosphere, and Atmosphere, which give rise to the biosphere. Let's have a good look at each of them. Starting with the Lithosphere, and to know about it, let's peek a little beneath the Earth's surface. As you can see, it is made up of various layers, out of which the crust and the upper layer of the mantle make the lithosphere, which is basically the solid portion of the Earth. The lithosphere is further divided into 2 parts: the continental crust, which is the thick part of the Earth's crust, which forms the large land masses, and the oceanic crust that could be found deep under the ocean and seas, which are denser than the continental crust. Now, let us move further to learn about the hydrosphere. You see, although the Earth seems hot and burning from inside, but when you look at it from space, you'll see one soothing cool planet due to its blue shade, as around 71% of the Earth's surface is covered by water. And this water-covered area is called the Hydrosphere. This 71% of the water is found in three different forms, that is, water located in a liquid state into the water bodies such as oceans, seas, lakes, ponds, etc. in a solid state such as ice and gaseous state such as water vapor. But always remember that out of the 71% of available water, only 2.5% is consumable by humans. So it is advisable that you consume water wisely and do not waste or contaminate it. Now, let us move further and look at the sky. I know you feel that the area between the surface of the Earth and space is a vacuum, or there is nothing in between. But let me inform you that a lot is happening there, as it is covered with a set of layers of gases we call the atmosphere that surrounds the Earth. This invisible shield of gas performs various duties like keeping us warm, providing the oxygen, and it is where the weather changes. The atmosphere is further composed of different layers, and each layer has its prominence. The first layer is the troposphere, the lowest layer of atmosphere that ranges up to 5 to 9 miles above the Earth's surface and is denser than other layers. The troposphere is where all of Earth's weather occurs and contains approximately 80% of the total mass of the atmosphere. Now, as we move ahead up to 31 miles from the Earth's surface, we enter the stratosphere. This vital layer absorbs harmful UV rays coming from the sun towards the Earth with the help of the ozone layer present in it. The next layer is Mesosphere, where meteors rushing with a high speed gets burnt up. And after that comes the Thermosphere, where the solar radiations are absorbed and you can witness the aurora in the same layer. And the last layer is Exosphere, which meets space. Now, coming back to the fourth domain of Earth that brings all the elements such as land, water and air together is our last sphere, the biosphere. The biosphere represents every part of Earth where living organisms are found that could be commonly divided into two main parts, the plant kingdom and the animal kingdom. This sphere ranges from the vast sky to the base of the enormous water bodies such as oceans. It is believed to be formed millions of years ago, where the first living organism to be created was bacteria. So, here we go, friends. These are the 4 domains of the Earth. We need to survive and thrive on this vast universe, and the Earth is the only planet to be blessed with it. So, cherish it, nourish it, and make sure not to do anything to perish it, because this is the only home we have, our beloved planet Earth. Trivia time! Did you know scientists claim that the Earth is approximately 3.7 billion years old, which also makes the biosphere to be almost the same age? Also, researchers say that the depth of the biosphere is complicated to measure, as there are fish known to be living
as deep as 8,372 meters in the Puerto Rico Trench. Hope you learned something new in today's episode. Until next time, it's me, Dr. Binocs, zooming out. Never mind.